Good evening and welcome back to Vegas October 1 Sounds. Tonight I'm going to give you a brief update on where I'm at with the establishment of timeline versus with alignment of videos. So, as you recall, I said that I'm going to be examining how to establish the shooter position and everything in a couple different methods, and one of those methods is to take various videos from that evening and align them with the marquee or a video source out front of the Mandalay Bay. And you do that by pulling up both videos and watching for unique events on the marquee, and these are light events, and then you align them, and from there then you take measurements and about where that event occurs, and then you can measure where the marquee event, where the audio sounds occur, and you can measure the difference. So let's go into a real example. Here you'll see that I have 6 different videos listed. There's a number more, but in this case we're going to be using volley 9, and we're going to be using the second burst of the volley, which is the longest part of the volley, and we're going to be measuring the first shot of volley 9 relative to that light event. So before we get any further, let's go look at the light event, and let's pull up a video which is recorded right in the venue. I guess I can go ahead and pull up a Las Vegas shooting map and show you where the first video is recorded. Alright, here we are. We've got the Las Vegas shooting map, and that's number 1 on my URLs to go to. That's just how much I visit it. And yes, thank you very much for the folks that put this together. So anyway, here we are. We're down here near Cop Corner on the intersection of Las Vegas Boulevard and Mandalay Bay Road, and then just slightly north into the venue we come across the VIP tent, and there on top of I don't know, I think it's a bathroom or something, you have a guy filming, and this guy, this video records 3 different volleys, volley 8, 9, and 10, and we're going to be examining the 9th one for the video event. Now, I've already done all the hard work and positioned this video right near where the event occurs, and in this case you see Mandalay Bay in the background, and you can see the top of the trailer that he's standing on, and then about middle of this picture at the top you'll see the marquee from the Mandalay Bay, that big old flashing sign out front, and it's kind of dark at the moment, and that's the type of event that I'm looking for, is something that goes light to dark or dark to light. So in this case, if I'm going to do a single step by frame, there we go. We see it transitioned to a light. So here it was off, dark, and there it was on. That's a very quick transition. It only took 1 frame. And those are the kind of events that I like to look for, because if it takes 3 or 4 frames to go from dark to light or light to dark, then you know which frame are you going to start measuring, and how far away can you see that. So in this case, if we go backwards, we'll see that the last dark frame occurred at position 53.600 seconds into this video. Okay, so I go over to my program, and you can see that I've recorded in that program on the across 53.6 for the end of the event. So the last dark frame I recorded, and I've done that for all 6 of these videos. And I record a starting position of this as 52.966. So let's go look for that in that same video. So we have to go back to 52.66. Well, I guess we can try the slider. It's not generally very accurate, but let's see if I can. 52, I said 52. There's 51, so that's close enough. Let's go from there. We want to go a second, almost 2 seconds now. So we'll just, there we are. We can see at the top the screen, and we're at there we go. It's starting to go dark. Now there's a little blue tinge around there, but that turns out it's the actual the light from the cop car down below. So if we back up a little bit, we see it's bright and it starts to fade, and that's the first dark thing, and that'll occur at 52.966. So I hop over to my program. It's actually put into an Excel spreadsheet, and I record 52.966 as the first dark frame of that event. And then the program will come along and calculate that the duration of that is 0.634 seconds. Alright, so what do I go from there? Well, what I do next then is I pull up the audio and I record where or at what time the event for the first shot of the second volley occurred, and I do that with Sonic Visualizer, and you've all seen me do that hundreds of times, so I'm not going to do that. But anyway, I pull it up and I note the time at which the muzzle blast, these are all muzzle blasts, there's no sonic cracks involved, is done, and I note that. And we do that now. We'll also do that now for before we go on discussing these numbers anymore, for the cop cam batch 7 number 38. And we're looking for the end of that event at 363.563, which is 6 minutes and 3 seconds. So here's the cop cam. Now I've kind of, alright, so we're at 603.563, and if you look here closely at the sign, which is kind of small, so let's go ahead and enlarge a little bit. Some information will scroll off, but what do we care? Alright, there we are in the lower left hand corner, which I can of course get a little bit more centered. Right above this guy in the yellow shirt, you'll see that the sign is dark, and if I step forward one frame, still dark. There we go. It starts to come light there. So the last dark frame is at 603.563, and I think that's what I recorded, 603.563. Yeah. And then similarly, we could go looking for the first frame at 19 frames later roughly, and let's do that. A little slow here. And how most of these video programs are, they love going forward, but they hate going backwards. So just depending upon how many frames I have to step. Although some of these videos are pretty good. I haven't quite determined what makes some of them go fast and some of them go slow. I haven't quite got there yet, so let's step it a big chunk here. We'll get 542, that's a little too far. 6, I think we wanted 6.1, didn't we? 609, yeah, well. 6, we'll start at 6. And there it's light, we'll just step forward until it starts to go dark, because that's quicker. And we'll zoom it in once we get the rough approximate place at which it fades. Looked like it wanted to there for a second. Oh, there's that guy. I should have noticed by him. Went way too far here. I'll get it. Hang in there. There we go. We can see some light or something coming up. There we are. It's turning blue. Alright, so let's magnify in now. I said magnify, not... That way we can watch it more carefully. Alright, now we'll step forward. It's light. It's going dark. Going dark. Going dark. Last frame is at... the first dark frame is at 6:02.962. Is that what I recorded? I put 995. Okay, so last time I did this, I determined that that was light being reflected from the cop car. So as you can see, even with this method, there's some ambiguity there, and that's why I dislike things that don't happen in one frame. But for sure, that's the first dark frame. So 6:02.995, and sometimes even these video programs get a little confused as to what the actual frame number is. Alright, 6:02.995, 6:02.995. And this time we calculated it as 0.568 in duration, which means there's a total of 2 frame differences here because of that inaccuracy in measuring the front, whereas the measure in the back, which would be the end, is very accurate. So that's, in this case, I've chosen to use the end point, where it's that 1 frame dark to light transition, as the point of reference, and you have to be very careful when doing this. Okay, so let's take a look at all these numbers. First off, you'll see that the ID over here represents which video I was in, and all these should be pretty common to you by now. That's the Oasis Apartments, the Raymond Page, the guy on top of the bathroom near the VIP tent, the Hebrew-speaking ladies in the parking lot of the Luxor Hotel, and to have some interesting reveal on that in a minute. People on top of the Excalibur. Now the Excalibur is way the heck down there, past the Blue Man Group and everything. So it's kind of an interesting point. And then of course this Cop Cam, which is right down there on Cop Corner essentially. All right, and I call this. I give the event the name 9 mid because actually for volley 9 there's an event that occurs prior to the volley, during the volley, and there's one after the volley, and I'm using the one that's in the middle. And to record the starting frame and the ending time, starting time and ending time, calculate the duration, and I'd give a mnemonic to the actual shot that I'm using, which is volley 9B shot 1. Record the time in the videos, and then I calculate the time difference between when the audio event occurred, i.e. the muzzle wave was heard, and the end of that light event, and I record that for every one of them. Now let's talk a little bit. Let's see, I'm going to have to probably do some drawing now to explain this. And well, that's kind of a messy desktop, so let's get rid of that. Alright, so we've got a sequence of shots being fired. Okay, and somewhere along in there, and I'm picking this one to look at and measure. Let's call that shot 1 of volley, and that's the second burst. And then we also have a light event which started somewhere over here, and 19 frames later, let's say, stopped right there. So what I'm doing is I'm measuring, in this sense, the time between the first shot and when that light event stopped. And if you're further away from the shooter, then these shots take longer to get to you, and therefore this whole waveform gets shifted. So, at a place that's 300 feet away, it would probably be shifted more than 2 seconds. Let's see, there's 1, 2, 3, 4, 5, 6. There's 4, 5, 6. And so as that shift occurs, the time between the event over here, which is the light event, and the start has shrunk, i.e. gotten smaller. And similarly, if you're closer, it gets larger. So on our, I hope I said that right. Let me make sure now. That thing goes that way. So in this case, the light event is in the middle of it. But in our case, I think I have just the opposite. So I'm going to have to revamp this statement a little bit. We have, let's see, the light event occurring at 83.2. Okay, so yeah, I got to redraw that. In our case, the light event was ahead of, no, after the audio. Yeah, that's right. So the audio event occurred at 80, and the light event occurred at 83, roughly speaking, giving us a gap of 0.29. Anyway, so okay, back to the thing. Okay, I'm still thinking about this, how to explain it the best. So as we have this what we have over here is, when I calculate the difference, you'll notice that the gap grows. Yeah, I'm saying it right. Okay, yeah, I'm saying it right. I wasn't messed up. So anyway, the further away you are, then the shorter the gap between the light event and the sound event, because it has longer time to shift. So the bigger gaps occur for the closer you are, which is just contrary to what you think about muzzle blast. And this is so because we're measuring an audio event which occurs prior to the visual event. So in our little table over here, what we've got on the gaps is we see that the largest one occurs for the on a cross, which is under the blue line here, which is the video recording locations. That's the closest. And the smallest one, which is 2.2, occurs for Excalibur. It's the furthest away. So it's just a little bit opposite of what you think. Now, had we been measuring a light event which preceded the muzzle blast, then it would be a slightly different situation. Alright, so let's erase that and get back to talking about these other numbers over here. So we got this gap. So now that we know how this gap works, we could order these in terms of who's the closest and who's the furthest. And under these video recording locations, we have crossed is the closest. Then we have the ladies in the Luxor parking lot, and then it's almost a toss-up between Raymond Page and the cop cam in terms of distance. Now, Raymond Page was at gate 2 at the time that video event occurred. And then we have Oasis being next to furthest, and finally Excalibur in terms of that. Now, the thing to note here is that on the cop cam we have extra numbers. And what I do is record the timestamp on the cop cam. So if we go over to the cop cam here, alright, and shrink it back down so we can see it. I think we're on, yeah, we're on the last, are we on the last frame? Let's find out. Go step 1. Nope. Let's get to the light event changing. There we go. Okay, that's the last dark frame. And in that case, the numbers recorded up here are 5, 12, and 39. Okay, so that's Zulu time, 5, 12, 39. come over here and you'll see that that's exactly where. But how close is that? How many, milliseconds? Because we have to know down to the exact frame. So then what I'll do is I'll go look for the spot at which that cop cam changed from 38 to 39, and you'll find, and what I did was find that the first frame at 5:12:39 occurred 6 frames including prior to this one, or 6 times 33 milliseconds, or 0.2 seconds prior. So this, consequently, then add those all up, or actually subtract it in this case, but multiply minus 6 by 0.033, which is like minus 0.201, and you'll come up with the actual time of that last dark frame as being Zulu time 5:12 minutes and 38.8 seconds. So now we have an absolute time for all of these events, because they all, for the light event, because they all occur at the same time. And then based upon the video times, you could then, and the audio times, you could then add in the appropriate change here and come up with absolute times for each audio event also, which you could then, if you believe this number, identify them in absolute time. Now that still doesn't tell us when those shots actually were fired, because we don't have a video that's recording this, actually recording the event in room 135. But it does give us something else that's really interesting, and that is we can now ask the following question, because if you take the time between each of these gaps here, you have essentially when the shot occurred at that, and you can ask, well, if I hear the event at Oasis, when will I hear it at the Raymond Page location? And the answer will be just subtract these numbers up there for Oasis and Raymond Page, and you'll get that you heard it a negative 0.321 seconds earlier. So if I'm at Oasis and I want to know when it occurred at Raymond Page, it'll be simply reading off this number going top to bottom. So in this case, Raymond Page occurred 0.3 of a second earlier. Across, the guy on top of the bathrooms, half a second earlier. The Luxor parking lot, 0.4, and the Excalibur being positive will occur 0.3 of a second after the sound is heard at Oasis. And similarly, the cop cam, which comes at almost exactly to the Raymond Page, will heard it 0.3 of a second earlier. And you can ask that for each one of these. And so now you can get a bit of information as to when these sounds occur in an absolute sense. Even though they're still relative to one another, you still kind of know who hears it first and who hears it last, even though you could easily determine that up here from the ordering of the gap. A lot of times people ask these questions, okay, if I hear this muzzle sound, at the cop corner, when should I hear it on the east side? And since you have to do these, well, from this table you could just read it directly if you had those videos recorded. With alternate methods, you have to try to calculate things out. And oftentimes people say, well, the distance between the east side and the west side is 1,000 feet, therefore there should be a delay of 1,000. Not true, because each point records the delay from the source, which is way up on the Mandalay Bay, to your location. And so you have to take the difference in when those propagations occur, and that's what this table does. All right, so we have kind of a handle down on an absolute time scale, as much as you can believe the cop cam, and you could arbitrarily, adjust this up, down, left, or right to fit any scenario you wanted. That is, if this cop cam is wrong by 10 seconds, then you just adjust all the numbers up or down after you did the calculations for them. And at some later video, I'll do those for you and print up a table. But anyway, but what we don't know is when the events occurred in Mandalay Bay. Now you could take all these things and pick either the earliest or the latest, and I would pick the earliest, which would be right across, and measure the distance to Mandalay Bay, divide it by the speed of sound, which we have to estimate and everything, and then come up with what I believe would have occurred at room 135. But that raises the question, okay, we got all these gaps now. What do these mean? That is, what do they tell us in terms of the shooter location and the nature of the speed of sound and the elevation at which the shooter was? Well, we don't really have enough data points to do a plot like I did for the lag, but what we can do is take the previous experiment where I took a bunch of videos, I measured, and I said, if the shots occurred at room 135, when would I hear the muzzle wave and the supersonic shock? So I measured the distance from Mandalay Bay base, which is the D column, and estimated the elevation at 331, and actually I came up with a speed of sound also, which I'm using in this one as 1242, which may be a little high, maybe a little low. That's something we'll talk about in another video, and come up with this table. And since I measured the lag, well, anyway, dividing the distance by the speed of sound will give you the muzzle when the muzzle arrives. And we talked about this a little bit in another video. And then if you subtract out the lag, since the shock wave always occurs first, you get when the shock wave arrived also. So now we can take this muzzle arrival time and do the same thing we did for when calculating it with the absolute times for video alignment. And so, for example, there's more videos here than down below, but if we wanted to know the difference between when the muzzle arrived at Oasis, which is 1.265, and when it arrived at let's see, Excalibur, which would be not quite, let's see, somewhere on the order of 0.3 of a second. Okay, and then we could take that and compare it to what we found out down here, which was, I said, Oasis to Excalibur, 0.3 of a second. So it kind of looked like we have some agreement there. Well, if I did that same thing for all of them in this way, all these 6 videos, then I would come up with a difference between them. And that's what this chart says. And you can see that it's symmetrical along the diagonal from top left to bottom right. And so these numbers on the upper side are the same as these numbers on the bottom, just read in a different way. And so for that particular example, Oasis to Excalibur, comparing the time delta arrival in one scenario with the time delta arrival in the other scenario, I was off by 20 milliseconds. Now for me, 20 milliseconds is a good number. That says that I've got roughly the speed of sound right, roughly the elevation right, and by doing the calculations for the muzzle wave and distance, I come up with approximately the same number as doing it by aligning the signs. And that's what this chart demonstrates. Now, tonight I'm not going to go into any deep calculations on how close this should be, because that's a non-trivial calculation. I'm also not going to go into finding the distance to the shooter. But since I've already assumed a distance in the forward-looking experiment, and these numbers look kind of good, then I can say I'm on the right track. How close? That's another story. But if we can get all these numbers down to something on the order of 20, then we're very close to identifying the speed of sound and the location from which those muzzle waves originated by comparison to our aligning the signs strategy. So, and that's what we'll have to look forward to in coming videos. Let's see if there's anything else here. These are just more charts where I do the actual calculations. In this case, with the forward-looking simulation, I calculated the path length from Oasis, from the source to Oasis, from the source to Ray, and subtracted them, and this would be the delta in path length. And then you would just take the speed of sound, divide it into that, and you'd come up with this number down here. And that's how we calculate the deltas to compare against the deltas right here. So all this is a fairly simple process, i.e. there's no big, the most complex math I use in all these calculations is squaring and square root. But it is critically dependent upon getting these numbers, in this case of the video alignment, and getting the exact frame right, and measuring the audio precisely, and then performing all these calculations in a reliable fashion. And up here where I do the forward-looking simulation, it's crucial to get the both the distance from the base of Mandalay Bay, the elevation of Mandalay Bay, the speed of sound, and in the case where we want the shock, also to calculate the lag. So you see there's more variables in this forward-looking simulation that can go wrong than there are with the alignment, but the alignment by itself and alone, how do we know that we're right? We can do all those measurements, but we still don't know that that's accurate. You always need something to compare against. You always need to look at this from 3 different approaches and make them all agree, and if they don't, then you've got some explaining to do. And that's the approach I'm using on all this. So is there any other takeaways from this? No. We can play with the speed in this program that I wrote. We can play with the speed of sound and the elevation, and we can kind of look at the effect on these differences. And what I've discovered is that the speed of sound is a critical factor, and i.e. if you vary the speed of sound by 10%, you're probably going to get about 10% difference out here on these numbers. If you vary the location, it's not quite as sensitive. That is, if you vary the location of the shooter, it's not as sensitive. And so I'm still sticking to my estimate of, if you put a sphere around room 135 that has a 200-foot diameter, I think that the source of the sounds were within that sphere. And over time, I'll try to shrink that sphere down and give you a more accurate estimate. Now that's for all of the volleys and all the single shots that occurred. None of them at this point in time can be identified as outside of that sphere. All right, unless I've made some gross error somewhere. So I did say that there was going to be one takeaway. So let's go over to the Vegas shooting map here, and this is for those who want to do detailed research and for LVSA to correct. This video right here, which is the Hebrew-speaking ladies, is not located there. It in fact turns out that it's located up here, right next to the hotel driving park up. And the reason I know that is because when I used this distance and plugged it into my tables, the numbers were 0.2 of a second off. And so I went back and looked at the video, and when you look at the video, you can in fact see some palm trees, and you can actually see, let's see, I think we can put this in 3D. No, I don't have the Google Maps up. But anyway, if you go into Google Maps, you'll see that there's a fence right here, kind of a valet fence, just posts sticking up. And then you'll see that there's some palm trees directly in the line of sight. But more importantly, if you draw a line from the Mandalay Bay Hotel outwards, you can see that it pretty well lines up with the video. It's just off a little, not way over here in the parking lot, which is at least a 5 to 10 degree greater angle. So LVSA, move that over to this area over there, and I put it personally. I put it. I'm gonna get close here so I can give you a good representation. I put it, let's see, right about where that blue blue, I don't know what that blue is, handicap or something. Between the blue and that palm tree is kind of where I put it, or no closer than down at these first things, but right up next to the curb in the yellow or the blue or the red. If I get a more precise location, I'll tell you. Alright, so back to this. Now you notice here that this is my programming environment, and I do lots of things every day, playing with experiments. That was an experiment with the first shots where I measured all the muzzle blasts and all the supersonic cracks and took some measurements on them with respect to what I thought was going on. Here's the experiments I do with plotting. That's my lag plot, where I took like 20 different measurements of lag and plotted it over, this is the one you're all familiar with, over the venue, and came up with this thing. Let's see, I've got other programs here that are going, oops, not that one. Oh yeah, I'm establishing a new database to try to consolidate everything, and in this database, this portion of it anyway, I'm going to have every point that I referenced with the longitude, latitude, and elevation, a mnemonic for it, a description, and then I'm going to associate that with videos. I'm going to have, go down here, locations both on my drive and on the web for those videos, and there are some videos that are disappearing even in the shooting archive. And that way I can, when I say point taxi, although I don't have anything here yet because it's a moving target, let's go to Ray 5G. That's the fifth volley, the third burst from the Raymond Page video, and it occurs at this latitude and longitude and 0 elevation. Then when I use a video down here, well, I'll have a consistent across all my experiments set of mnemonics with the elevation, the type, the latitude and longitude, the URL on the web where I can find it, a description, and a location on my hard drive where I can find it, because it's just getting out of control, quite honestly. There's just so many videos and so many bits of information that spread across various different things that I had to consolidate them, and I'm still consolidating them. And anyway, that's just some of the stuff I'm doing. So anyway, that's the progress report, and 2 or 3, 4 or 5 days from now, I'll give you another progress report. Anyway, take care. We'll grab you in the next one.